Hello, welcome back to History of Wine and the Vine. I'm Emily Kate. So today I wanted to discuss a little bit about archaeology and how it relates to the history of wine. So archaeology is fairly scientific when you come down to kind of how you analyze things, and that's something that I know that I was interested in, and based on some questions that I've been receiving lately, I can tell that it's of particular interest to you guys as well. So I kind of wanted to delve in and do a little bit of research and find out how it is that we go from finding something in the ground to reading an archaeological source like the ones that I use a lot. So I first kind of looked and tried to figure out just about it in general. So first off, we'll start with, we're very lucky that studying the history of wine is a liquid, and what that means is there always has to be, whether it's being made or stored or transported, there's always going to be some kind of container. Now, unfortunately, organic containers such as wood or skins or bladders, they will not have survived throughout time until now for us to look at them. But clay containers have survived. So this is something that's really useful for us when looking at the archaeological sources, is to look at these clay containers like amphora and to kind of look at what's on the inside and try to figure out whether or not there was wine inside. Now, the good thing is that wine needed something to be carried in, but the bad news is the things that these kind of amphora were not only used for wine. So just because you find an amphora doesn't necessarily mean that there was wine inside of that. There could have been oil or some kind of other juice. So it kind of got me curious as to what these people look for in terms of when they're analyzing it to see that it was wine. And I came up with two main things, which is tartaric acid salts and syringic acid. So syringic acid is kind of from tannins and it has very pigmented, it's from red wines. And then tartaric acid, you might be familiar with tartrates, which are kind of found, if you chill a white wine and you're swirling it in the glass and you see these little white things floating in it, those are tartrates. And tartaric acid is really kind of the big one that we're looking for when we look to see if something is wine, because the great thing is that it's very unique to grapes. So grapes, let's say they're low acid, ripe grapes, they might have 4 grams per liter of tartaric acid in the resulting wine. And if they're underripe, they could have 4 times as much. So you could have 12 grams per liter of tartaric acid in your wine. And what this tells us is that this was indeed wine, and the reason being is that tartaric acid is not really found as commonly or abundantly in other types of plants, like other types of fruits. So you might have citric acid, like your citrus fruits, or you might have malic acid. And these things are more common in other fruits, whereas tartaric acid is really quite unique. Especially in most areas. There are some areas where they have a couple of fruits that have tartaric acid, but in its particular compounded way, very unique to grapes, which I think is a great thing, a really interesting thing, because now we know when we're looking at something that has the tartaric acid that it will probably, most likely, have contained wine, which is great. On the other hand, it's important to note that just because something doesn't contain tartaric acid doesn't necessarily mean that it didn't house wine. Something I read that I thought was interesting is that when archaeologists are kind of looking at an amphora, they'll think about how big it is, and they'll think about how high it was filled up. So it'll probably have like a residue, maybe a reddish brick-like residue, and based on how high it was filled up, they can kind of figure out the volume and how much wine would have been in there, and then they can say, okay, that means we're looking for X amount of this or that. And so that brings me seamlessly over to how they kind of analyze this sediment that they find and how they kind of figure out what was in there. So there are a lot of different ways that you can analyze this sediment, and there are ways that don't harm the substance at all, which I think is really great. So there's infrared spectrometry, and this was recently used for Byzantine amphora in Egypt and for Golden Age jars in Godin Tepe. So these are really great and very useful ways of figuring out exactly kind of how things are being used, like how these amphora were being used. And a great way of doing that is also through nuclear magnetic resonance. And what this is that the nuclei in a magnetic field absorb and re-emit electromagnetic radiation. And judging by what gets re-emitted, you can kind of do analysis on the different isotopes and the different things that are being analyzed, and you can kind of figure out what's going on within these substances. And another pretty interesting way of figuring out what these substances are made out of is chromatography. Now, I don't know who else absolutely loved doing chromatography in high school, but I was way into forensics and I did a lot of chromatography. So there's tons of different types of chromatography, and they're pretty much all used in archaeology for history of wine. And they include gas chromatography, thin layer chromatography, paper chromatography, high performance liquid chromatography. So what does that mean? Essentially, when you have something that you want to, so you have a solution, kind of like a compound, and you'd like to separate the components of it, those components will kind of travel at different speeds when you send them through something. So I know this is a very hard thing to kind of visualize. So I kind of put together a quick little, very simple, very rudimentary chromatography experiment today to do with you guys, which is a lot of fun. So what I did was I just took, I had a little, this is rubbing alcohol, and then a coffee filter that I just cut into kind of a slice. And then I took just 2 Sharpies that you can get anywhere, and I made little dots right on the coffee filter. A little bit higher up, I made 2 dots, and then I kind of placed it inside inside a cup that also had the rubbing alcohol in it. And what happened was it traveled up. So the rubbing alcohol is kind of like the solvent, and it kind of the moving agent, and it moved the different components that made up the ink from the Sharpie, and it moved them up the kind of solid paper. And this is what resulted. And as you can see, so originally the dots were kind of on this level down here, and the dots have actually moved up, and this was a black dot over here, and if you can see, it's actually now looking purple. So what we can gather from that is that the black ink was made with a whole lot of purple components, and then over here this dot simply just moved right on up. So this is kind of what chromatography is this kind of separation. So the black down here, and then getting purple, 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 and then it's actually quite a light purple over there at the end. I think you can see that. So this is kind of what chromatography is, but obviously the people that are doing archaeology are not dealing with Sharpies. They're actually dealing with the sediment that we talked about that's on the inside of the amphora. So the inside of the amphora, what they do is they scrape away kind of that residue, and what they'll do is they'll actually mix it with this powdered solid potassium hydroxide, and then they'll heat those two together. Then they'll kind of immerse it in water, and then they'll acidify that solution. And once that solution is acidified, then they can kind of analyze it using chromatography. So once you analyze something using chromatography, you get something called a chromatogram, or you can make something called a chromatogram, and that is kind of a graph that looks like this. So why this is particularly of interest to us is because this is what a chromatogram of wine looks like. So you have the syringic acid we talked about, vanillic acid, and gallic acid, and so you have the milliabsorbance units, which is on the y-axis, and then time, which is on the x-axis. And why this is really useful is because of the ratios. So if you have these type of ratios, you know that something is wine. You know that that was made out of grapes, and if it doesn't look like this in this type of ratio, and it doesn't have these kind of components, these compounds aren't present, then you can say that it's probably not wine. Or if it has this and more, maybe it's a wine mixed with something else. So it's really interesting to kind of look at different chromatograms and see what the different ratios are, and to see kind of what other substances that were carried in these amphora, how their chromatograms look and how they differ from this one. So I hope that this was kind of a fun and interesting kind of sciencey history of wine episode. And I hope they kind of clarified a couple of questions if you might have had about archaeological sources. And I will see you next week. Cheers!